Good day. Today, I will present my paper titled in the Domain Implementation Method and the Case Study in SunRoof Control Domain. And my name is JeongAh Kim. I'm working at Catholic Wanda University. I will present my research as following agenda. At the first, I will briefly explain the software product line engineering concept. Software product line engineering focused on software product line, not each application. As you know, the one software meets one customer's requirement, but there are so many similar requirements among the different customers. If we have a if we have a common architecture for similar requirements, we can produce the software quickly based on a common architecture. So it is the starting point of software product line engineering. In software product line engineering, variability is the key success factor because a software product line use variability mechanism to generate or to customize the software product line to each different product. This is a big picture of a software product line. In a software repository, there are feature model, architecture, and the reusable components. Reusable components include source code and several kinds of artifacts to explain the code. At the product instantiation stage, we can select what feature should be included product or what feature are excluded from a product. Based on selected feature and variability management mechanism, new product instance is generated from the repository. So in software product line engineering, we do not implement the software from the scratch. Based on software repository, we select what feature we need and configuration management or configuration environment generated source code for new product based on software repository of a software product line. Of course, all requirements for new product cannot be generated. Customer specific requirement should be customized or new module should be added for new customer specific requirements. But the most important features are already built from the software product line because new product also belong to the software product line. It means new product can share the lot of features and a lot of core assets. It means yes, the many requirements and many components can be shareable and reusable. I already explained the shortly feature model, but the feature model explained the commonality and the variability. Feature-driven development uses features as an object of a software engineering. Using features, we can determine the scope of the project. Feature is the most popular and powerful key to manage the variability. This figure shows our feature model, for example. It is the feature diagram, and this is the feature configuration part, and this is the list of feature. A feature diagram or feature model identified the features with the variability information. You can see the optional feature and the alternative feature. And the feature diagram also presented what is the capability feature and what is operational environment feature. So with the feature, we can define a project scope and the project characteristics and variability information. Also, feature model gives the direction to design considering the variability management. So based on this feature model, we need a detailed guideline how to design the component to manage the variability. This is our research scope. In this research, we are based on this process. At the at the development of a product line, we define a feature model for variability modeling and implemented the feature with the code or related artifacts. When a new customer comes out, project-specific adaptation will be proceeded, and then we decide what feature should belong to the new product with the product configuration. Our product configuration generates a product with reusable assets stored in the library. This is our production process. To to success our production process, we need a, a very detailed variability management and variability the, the variability information in a different model should be consistent. We adapted our suggested guideline to automotive manufacturing company. As you know, that these days automobility are evolving into an electronic device. So the nature of the industry is changing from the mechanical engineering to software engineering. This company also hoped to shorten their development time for various customers and efficiently reuse the previous efforts. So for these reasons, this company decided to adopt software product line engineering technology as a solution to increase the reusability and the maintainability of their software. This company manufactured the SunRoof system. Of course, SunRoof is itself an operational part of a car, but these days many car models adopt the sunroof, and each car model has a different characteristic of different features of sunroof. So we think that it is a very proper domain, so product line engineering adaptation. We identified 80 features. Among these features, there are 3 optional features and 9 alternative feature group and 20 alternative features. With these features and feature attributes, we separate the module and for managing the variability. In this research, we suggested guideline for um, reference architecture construction activities in domain engineering. Especially, we suggested variability modeling at the architecture construction, and also to evaluate our guideline, product configuration activities are performed. We define a mechanism for handling the four kinds of variability. Variability in state, and variability in state transition, and the variability in algorithm, and the variability in operational condition information. We suggested a guideline how to model the variability, these kinds of variability in each software model, and how to implement these variability in a source code. This slide shows the case study in state variability management. There are optional uh, feature. If we don't need this feature, comfort condition control, this is a behavioral model without this feature. But if we need this feature, the behavior model is changed like this. New two states are added because of these optional states. With this variability, in product line engineering, we should have a model like this. And also, we suggested it is a very small character, but our new stereotype VOP, variable optional stereotype, should be modeled for describing these states are optional because of it is related it is mapped with the optional feature. So if this feature is not selected, this VOP state should be excluded in a state model of a new product. And the second case is um, state transition. In this case, we have a mandatory feature, but we have a variability in a feature attribute. This feature has two kinds of attributes. First one is a three-way switch, and the second one is a three-way second switch. The feature is mandatory, but with this feature, there are two kinds of feature attributes. In this case, in the architecture model, the component should define a VAP characteristic. VAP tag means variation alternative point. In this research, we suggested this tag means there are some variability in internal implementation of the component. Variability in internal implementation means the following slide. What kind of a feature attributes are selected? State transition, both feature, we have a same state transition, but different condition should be defined based on a feature attribute of a mandatory feature. So we should model a variation point at the state transition. State, tran state transition should be defined with a variable information to meet the feature attribute variability. And this case um, is variability in algorithm. For implementing the module and implementing the algorithm in a module, detailed design consists of interface declaration or interface definition and algorithm uh, in, algorithm implementation. With the interface, we can easily replace the implementation model. So we suggested a new design pattern to separate command and command implementation. Left-hand side, we have two kinds of module, and these two modules define command and the command implementation together. But in this case, the new command come out, we should change, we should modify the internal of the two modules. So to separate command and command implementation, we suggested a new model, the interface module and the implementation module. So command and for command, we have a command interface, and for command implementation, we should also define a command interface for command implementation model. So new two module should be added for separating the interface and implementation. So to evaluate our um, suggested guideline, we select two products. Each product has a specific requirement like this. Uh, this is related with the optional feature, and these are related with the alternative features. Based on this product configuration, based on this configuration for product A and this configuration product for B, we can select a feature for each product, and based on the selected feature, product configurator generate the document and the product implementation code. Since the documents are more clear to understand, we capture the generated document. If optional features are selected, our configuration generated left model. If the optional features are not selected, right model are generated. Of course, implementation code also the same based on a selected feature, the variable part, sometimes variable part, the source code contain a variable part, sometimes based on optional feature, without optional feature, the variable part uh, are excluded from the source code. This is the another evaluation result with related with the state transition model. So evaluation result shows the product architecture is consistent with the product line architecture, and the product line architecture is consistent with the feature model based on our suggested design guideline. Okay, this is the conclusion. In this research, we suggested how to model the variability in architecture and module design based on a feature model. With this guideline, product line module are implemented with the source code with the variant. And based on the selected feature, source code with the variant are deployed to the source code for product instance. With our guideline, we successfully construct a SunRoof software product line for the company and successfully instantiated the two products based on a software product line. This company will generate the feature product with the construct of their product line, and also this product line will help the developer how to design a software model to manage the variabilities. Um, Thank you for your attention, and this is the end of my presentation. Thank you.